So let's look at the third device, which is our Enhancement PMOS. So that's this one here, so the third one down, and we can see the threshold voltage here is -1 volt. So I've set that up already, so it's sitting at -1 volts. You can see here it's a P-type and a P-type for the source and the drain, and the N-type is the substrate. Now remember that what we have here is the charge carriers are going to be holes. In this instance here, holes travel from a positive voltage to a higher voltage to a lower voltage. So it means here, in this instance here, if we were to go in and then set the gates, drain and source voltage, we'll leave the beta values and everything, width and length, just the same as they were previously. So we go in here and change these values. So we could set off, and we know that we're going to have the source of the holes is going to be the high voltage side this time. So we could set that at, say, 4 volts, and we could put the drain at, say, 2 volts. Now in this instance here, we can see here that we've got a channel existing all the way along this. We've got an inversion layer all the way along the channel. So the holes are actually going to be travelling from the high voltage, which is the source, down along the channel and out through the drain. And you can see here it's actually in the linear region because the channel is all the way along, and we can adjust this by adjusting the drain voltage. So we adjust the drain voltage down, then you can see we can get it to get into the saturation. That's in saturation, and that's in the linear region. So again, we could also make it the other way round about, so we could actually make the drain voltage higher than the source voltage, in which case the device would swap round, and this would now be the source and this would be the drain, and the current would be flowing in the opposite direction. But we're not going to be using the device like this. We'll just use the device in this region here, the same as we did with the previous devices. So in terms of its switching, you see that this device here actually operates in the opposite sense from our Enhancement NMOS. So this is now the Enhancement PMOS. So in the Enhancement PMOS, you can see here that whenever the gate voltage is sitting at 0 volts, the device is going to be on. But whenever the gate voltage rises up to 5 volts, you can see that this is getting, the depletion region is getting smaller. That's the inversion region is getting smaller, until whenever the gate voltage gets up to the value of 3 VGS minus VT becomes a value of 0, we're going to then have the device cut off. So if we're up at the 5 volts, you see the device is hard off. That is, it's not drawing any current. So this is the opposite, as I said, of the enhancement. So the Enhancement NMOS, the device is off at 0 volts and on at 5 volts. And this Enhancement PMOS, the device is on at 0 volts and off at 5 volts. And that's very handy, and we're going to make use of that whenever we come to doing our digital designs. So that's all we really want to say about this device. We will actually be over whenever this video and the next video is finished, we'll do a summary of what we've learned here, and it's only just a small summary of what we're going to, the device characteristics in terms of the on and off values. So in the next video, we'll go on and we'll look at the final device, which is going to be our depletion PMOS. And that'll be us finished with the device types, and we'll be able to start looking at some more interesting stuff on actual digital design. So thank you for listening. I'll get you in the next video. Goodbye.